how if we're integrating up to a variable. And look what
I
happens
checked
there.
it before you got started. Oh.
Yeah.
So this one is asking us to write as an integral the solution to the initial value problem, dy dx equals secant of x, and y of 2 equals 3.
Okay.
So what does a dy dx tell me?
Yeah,
That's the
okay.
derivative.
Yeah. Okay, thank you.
All right. What's this thing?
That when the original function equals, when x is 2, y equals 3.
Mm-hmm. Okay. So I'm asking you to write this as an integral. Okay. So that the derivative is equal to secant of x. So we know that we looked at yesterday, if we integrated from a constant up to x, we could do just plug in the x when we did the derivative, right? So I know this will be an x. We need a different variable here, so maybe a secant of t was the one we usually use, dt. Since this is initial value, initial means starting, so 2 would have to be our starting point. Okay, so far let's see what requirement is met. If I did the derivative of this integral, do we get secant of x? Yeah. The derivative of the integral, they cancel each other and you just replace your variable with the x. That's what we learned yesterday. So this requirement is met, but I don't know about this one. So we need to figure out what we can do to this. This is like my y, my initial. When I plug in a 2, I need to get 3. If I plug in a 2 for my x, what's the integral from 2 to 2? 0. So what we could just do is add that 3 on the end. Okay, so check your requirements. This is my function. So the derivative of it, the derivative will cancel the integral. My t would change to an x. Derivative of 3 is just 0. That goes away, so that requirement's met. Y of 2 equals 3. If I plug a 2 in here, this integral turns into a 0 plus 3 equals 3. So this meets our requirements. This is my function. Okay, a little bit different than the other initial value problems that we've done, only because this one said to write it as an integral. That's why it turned out a little bit weird. Okay, I think I am going to go to, I want to go to example 11. If I want the fundamental theorem of calculus to find the derivative of this, I should have a dx on the end. Sorry about that. Typo on my part. Anytime you have an integral, you should have a d something on the end. So the fundamental theorem of calculus says if I do the derivative of this, what happens? Mm-hmm. And what will my variable become now? Square root of t squared plus 25. G of x is the integral of this function. So G of x is the integral from 0 to x of sine cube t dt. And I'm asking you to find g prime of x. So what would be the derivative of this? Mm-hmm. the initial value product. So it's saying the derivative is tangent of x. So we're trying to find the original. So it'd have to be the antiderivative. Where would this one start? From 1 to x, okay, of? We need to change variable to something other than x, so maybe a t, dt. Okay, so the derivative of this is tangent x. How do I take care of this requirement? Put plus 2 on the end.
Will that be like that every time?
Mhm.
Okay.
As long as you start your integral at whatever x value is given in the ordered pair, then you can just add that constant on the end. So this isn't technically the only solution, but it's the easiest. All right, so you have time to work on your homework.